I'm refreshing, our two other panelists have mentioned our task today is to contrast the sustainable materials management and circular economy. I didn't really like that question, so I'm going to talk about some other stuff. I want to begin with why we're talking about materials at all. And there are imperatives that I just want to focus on. First of all, if you look at our world, we live more and more in a materials world. We live in a world that has resulted in tremendous shifts. So if you look at our materials needed for energy production and use, 300 years ago, it was very simple. As we've moved through the internal combustion engine, and today we're looking at solar energy and fuel cells and hydrogen technologies, we have the whole periodic table of elements that we need to sustain our modern standards of living and ways of life. However, at the same time, we're bumping into real constraints, real problems. So you may be familiar, in academia, we love this planetary boundaries concept from Rockstrom and Stefan. They said, okay, there's about 9 different major areas of planetary health: biosphere, climate change, stratosphere, air quality, oceans, fresh water. And we are actually impinging upon the planet's functionality in 2 of these areas, very obviously: genetic diversity and phosphorus and nitrogen loading to water. Those are the red areas. In yellow, we're very close to hitting that boundary or exceeding that planetary boundary on a number of other areas: land change, climate change. And in the green, there are other areas at risk. This is very much sort of the ecosystem view of the world. They updated this several times, 2015, this is the latest update. At the same time, we live in a society where issues of equity and fairness and poverty are also profound. And the Sustainable Development Goals have, I hope you've heard of these, the Sustainable Development Goals have been announced by the United Nations. And at the same time as we address these issues of the planetary boundaries, we also need to be considering social and intergenerational equity, things like labor and equality. But there's a whole slew of characteristics and considerations there. Why are materials important in this? My simple equation is we spend a lot of time focusing on something like cars. Steel is actually one material, and steel is just as important as cars are for the entire global economy in terms of its footprint. So if you look at, I just pulled up the US greenhouse gas emissions by sector. If you look at transportation on the right-hand side, cars account for about 10% of US or global, roughly, greenhouse gas emissions. If you look at industrial emissions, steel accounts for about 9%. So they're roughly the same. We spend so much time thinking about cars, we don't spend the same amount of time thinking about materials. And if you go beyond steel, about 20% of global GHGs are associated with industrial material production. This is just the production. Because the steel also goes into the car, so you've also got that sort of life cycle consideration. We have a solution for cars. We have a solution for transportation. We have a solution for buildings. Yes, it's a pain. Yes, it costs money. Yes, it's going to take a long time to do. Electrification is the obvious solution for cars. We're working on that, whether it's hydrogen electrification or battery electrification, you know, and there's going to be modifications and tweaks on that. But we know a way out as far as greenhouse gas emissions associated with cars. We don't have a way out for materials. And I'll keep on harping about steel here. So steel is incredibly important. As I say, about 10% of the world's GHG emissions. Steel goes everywhere. And we can think of other materials as well, but steel is sort of one of the biggies. It's in our buildings, it's in our bridges, it's in our transportation devices. It's everywhere. It's in this massive infrastructure. Colleague of mine, Daniel Mueller in Norway, did this amazing study they looked at the materials flow, basically how much material is coming into the economy and where it resides in our economy. And they looked at major nations around the world. And what they determined is if you look at mature countries like Japan, Canada, the US, France, there's about 10 tons of steel necessary to sustain our modern society. So just looking around us now, our tables, the building, the vehicles outside, the fencing, the bridges, the pipelines, that's a stock of steel. It's about 10 tons that is static. It's sitting here and providing our way of life in Canada. About 500 kilograms of that is turning over each year in our recycling, in our waste, what have you. Of course, this demand is still growing as India and China and other nations come online, and consequently, the greenhouse gas emissions just associated with steel are going to continue to increase as we fulfill that destiny, that 10 tons per person as we move forwards. So question, and I do want a number here. How circular are we? And I'll give you the sort of the equation. What percentage of material resources that are in use that are recycled or reused? So how much of the material is going around right now? Give me a percentage of all the materials in all the world. How much is actually circular? 25%. 10-5. Okay, we're in the ballpark. Study out of Vienna determined that about 6% of the world's materials, as of 2005 when they did the assessment, 6% are circular. You can see from this Sankey diagram, on the left-hand side you have the extraction processes, but interestingly the yellow is fossil fuels and the green is the biomass. Pretty much all that gets combusted. It's not circular. It goes through once and it ends up on the right-hand side as output. So, but it is material that we're extracting from the ground. If you look at the lower half where it's the red and the yellow, the bulk of that is construction materials, and then there's a little bit of metals in there and a little bit of other stuff in there, but a lot of it's going into stocks. It's going into those bridges, it's going into those buildings, it's going into those tables that sit here at the university for 10 or 15 years. You can see the recycling loop is that 6% that they quantified, but we have this tremendous stock that's still building. They also did the study for Europe, and they determined for Europe it was a little bit better, about 13%. Europe has the advantage that they don't have the same sorts of biomass or energy profile as the rest of the world. And they have additional recycling capacities as sort of a more mature recycling economy. But still, 13%, 6%, we have a long way to go. I want to talk about the virgin materials, the primary materials coming in on the left-hand side here. So we know that there are also problems of constraints there. We haven't talked about that, but it is sort of part of the broader material resource discussion. So we have environmental and social constraints on extraction of primary materials. It's not acceptable to do things without environmental permits. It's not acceptable to do things without the permission of the landowners, particularly the indigenous peoples. Market and economic incentives actually distort the types of things that geologists go and get. Geologists spend a great deal of time looking for gold. Oh, useless. It makes me mad. But they don't spend enough time. There are not the same incentives to get some of the more important things on that whole periodic table of elements that are necessary to sustain our modern life. We don't need gold in our modern life. Only about 6% of that gold is used for practical, utilitarian purposes, not to say that jewelry isn't important, but time frames are getting longer for extraction of materials. From discovering a deposit to actually getting an operating, that time frame is actually increasing, and new discoveries are not being made in those areas that we need it. So we have an interesting distortion that the primary material constraints are actually something we're starting to bump into and something to get concerned about. A colleague of mine in Australia, Stephen Northey, has looked at, for example, copper. So on the left-hand side here, the plot shows year on the x-axis from 1900 to 2000 or 2100, and grade. So the grade of the ore that's in the ground that is being mined at any moment. And he looked at a bunch of different countries. But what you can clearly see is the grades have been going down over time. Of course, we go and pick up the rich ore that has lots of metal in it, that's at the surface, that's convenient to get, before we go up into the Arctic and dig deep down under the ice and pull out the rock that has lower quantity of ore, of mineral in it. Of course, lower grade on the right-hand side, the lower grade requires more energy in order to extract it. More energy means more money, more costs, more impacts in general. So you have this tendency also that as grades are going down, the costs are going up. So you have this interesting primary resource constraint that is forcing. So what are we going to do about it? What are we thinking about? Oh, recycling will save us. No, it won't. Recycling is important. Recycling is very important. Recycling is a big part of the solution, but in and of itself, it won't save us. We need to understand, and there's a bunch of studies like this where we look at a time frame, in this case, again for copper, over the time, and looking at production. What is the shift from primary to recycled? And what's the timing on that shift? Are we going to replace our primary production with sufficient secondary or recycled production in sufficient quantities to maintain enough material? And most of the evidence suggests that we won't be able to ramp up our recycling. And the major concern or the major limitation of that is the material in stock. The material, it's not necessarily the recycling technology of getting, steel is quite readily recycled, but because so much steel is still going into buildings and pipelines, we don't have enough coming available to meet our needs. It's not enough. In my work, we did a study for lithium, and we worked at different dynamic modeling scenarios going into electric vehicles, and we looked at the possibility of primary, of recycling, and of reuse of electric vehicle batteries, which is a great idea, but it prolongs the use of the battery in the economy and delays the opportunity for recycling. So there's all these dynamics at play, and different scenarios have been worked out. The steel guys, again, steel's a very mature industry. We have significant infrastructure and technologies for recycling steel. In the US, there's more steel going through recycled sources than there is from primary sources in the US in a modern economy, mature economy, versus in China, there's still more primary than there is recycled. But what we find is there's still this delay. In the blue, the secondary production, the recycled production, is delayed because all these materials are caught up in the economy, and we still need the primary material. What about bio-based? Yeah, what about, this is, who's that? I won't. That book, what's that book? Cradle to Cradle, yeah. McDonough and Braungart. First 3 chapters are pretty good. I actually require my students to read those. Then it breaks down. But they talk about, and we've seen all these diagrams of loops of biological materials and technical materials. You can find thousands of these dizzying diagrams on the internet. Good stuff, I like it. I want to believe in this. If we pull this apart just a little bit, it actually looks like this. The biotic economy, the biotic materials economy, is 1/10 of the abiotic, less than 1/10. We still rely greatly on these technical materials, the minerals. The modern society uses those minerals, those fossil fuels, those plastics, those metals, and it's much greater, and it's actually getting greater compared to the wood and the cotton that makes up the biotic. So again, I'm not saying that biotic materials is a problem, it's just, it's not something that's going to save us immediately in any way, shape, or form. Circularity. So this is this old idea that's come around. And just to riff off my colleagues here, I did break down and put up a couple definitions. I've actually chosen this definition from Technical University of Delft. It was just published in my journal, Journal of Industrial Ecology, 2017. The reason I chose this is because the second author on this is Connie Baker. And Connie is the brains behind a lot of the European circular economy thinking. So the European Commission goes to Delft, and Delft guides a great deal of that resource efficiency circular economy thinking. So this is a new definition out of Technical University of Delft, and I just wanted to emphasize a couple things. They talk about circular economy as a value of materials being preserved, looping materials, of course, but also, my colleagues, we haven't emphasized lengthening the period of the life of products. So that's just something that they've put into their definition very explicitly. The notion of waste no longer exists in their definition, and they also, of course, pay credence to energy input should be derived from renewables. I had to go back to the OECD 2012 Sustainable Materials Management definition. I think my colleagues have spoken about this. Just to contrast these concepts a little bit, I see the circular economy as being more of a visionary concept. The sustainable materials management is more of a policy approach. The circular economy has this preventing obsolescence. That's the way that the Delft people talk about it now, is that we're trying to prevent the obsolescence or the retirement of those resources. Where sustainable materials management likes to use the more engineering terms of maximization and minimization, circular economy tends to have more of a design and product focus. It excites the architects, it excites the interior designers, it excites many companies that present themselves as novel product providers. Whereas sustainable materials management, a little bit more boring, we're talking about materials and waste. The looping or the recycling is present in both. The lengthening and intensity of use is something that is somewhat new in the circular economy lingo. It's not new if you go back to Walter Stahl in 1972 in Switzerland, who is now working for EMF. But these, you know, there's some strategies that are present there. The ornery person in me says, well, the circular, it's very hopeful, it's kind of romantic, it's kind of populist, it's a little bit naive, but it's a young concept too. It's a fairly young idea. It's a terrible term, circular economy. No, but what does that mean? So anyway, academics don't use that term. We talk about circularity instead, but we're chasing it around as well. There's a whole pile of articles that are just coming out in the peer-reviewed literature on circularity in different journals. So this 2017 one is one that I like that just came out. I'll just move on from there. Of course, the hierarchy is present in this, and one way of thinking, I don't really like this, but I put this together. If you think of this entire hierarchy, the sustainable materials segment is perhaps more that recycling focus, which you've emphasized. The strategies for material circularity. Now, I picked this up from Allwood and Cullen from University of Cambridge, who had done a lot of that steel work as well. And what they point out is that recycling isn't going to save us. Recycling is absolutely necessary, but we need these other strategies as well. And they tried to quantify out these strategies. Reducing demand, which is a very preventative strategy. Longer life goods, so that goes back to the Delft concept of extending. Using less material in our designs. We over-design stuff. We over-design. We're fixated with this bloody concept of risk and safety. We put way too much material into so much of what we do. Yield losses, scrap recovery. We can actually reuse materials without recycling them. And they have a great chapter on how you could do that. And again, going back into sort of more engineering solutions about diverting scrap. So they have a great book, Allwood and Cullen. It's called Sustainable Materials, a beautiful book, very practically, and they quantify the benefits of each of these strategies. One example from my experience, so we did a study 5 years ago here. It was a joint work between Faculty of Environment and Faculty of Engineering on extending the life of lithium-ion batteries. And we took discarded batteries from electric vehicles. The concept there was that when a battery reaches about 80% of its energy capacity, it's no longer serving full mobility functionality, but it's still an 80% good battery. So we said, well, can we repurpose that capital investment, repurpose it into a stationary application, and take that life cycle and give it another cycle, which is actually a longer duration than a vehicle which might last 8 or 10 years. We could put it into a stationary application for 12 or 15 years as backup power or power shifting. What we found is technologically, economically, and environmentally, this was a pretty good idea. Interestingly, the barriers are not the technological barriers. We could figure out a way of doing the software. We could figure out a way of doing some of the remanufacturing, of reconfiguring, of disassembling in certain ways. Yeah, you had to sort of think about the cost of energy that you're displacing and how much labor you're putting in. But the interesting barriers were socioeconomic and institutional. And this sort of goes up that hierarchy as well. I'll come to this in a moment. So it's building codes and insurance companies. They're not familiar with putting batteries into houses. They're not familiar putting refurbished batteries into houses. Fire standards, there's safety again. Financing and ownership. The car company really does not want the liability associated with their name for a battery that is no longer in a car and going somewhere else. So it's really these social and institutional barriers that need to be more deeply addressed and reconsidered if we want to get to these ideas of circular economy and sustainable materials management. Interestingly, there's this company called Tesla that I think is, and I'm fascinated with Tesla, I'm fascinated with their technology, but I think the bigger issue is not the technology, it's actually the normalization of what they're suggesting. They're normalizing electric cars. This is their power wall. They're normalizing and socializing the idea that you could put a battery into a house and control your own power and have that kind of device. They're the ones that are going to talk to the insurance companies. And that's the sort of change that's going to be much deeper because that affects entire markets and entire segments. The other bit that I've started to look at is business innovation. So on the right-hand side, a picture here. So this is the life cycle of a single product. The point that it's created on the left of the blue to the point of discard, and then there's actually a physical end of life that it sits around for a bit before you actually throw it away or landfill it or something. And then intensity of use on the y-axis. So the intensity of use of a typical, take a very extreme example. A Black & Decker power drill that I have in my basement gets in its life about 5 hours of use. I pull it out, I put a bit in, I turn it on, and I've got a new hole in the drywall, and then it goes away. The intensity of use of a product like that is really weak. So we can think in terms of how you provide greater intensity of use, greater capacity of use, greater frequency of use, greater ownership of use, sharing of use. And this largely is a business construct. It's a socio-institutional, it's a business model. So there's companies like Fairphone, which has repairable modularized phones that you can repair yourself. There's Mud Jeans, which is doing reuse or leasing of the clothing product. You have the Toronto Tool Library, which enables that single power drill to be reused or to be used every weekend by an individual. So the intensity of use goes up. So these are interesting business innovations that I think we should keep an eye out for. Walter Stahl, who I mentioned earlier, who, in my opinion, is the father of circular economy from the 1970s, because he did some very good thinking on the performance economy back then. He said, why own anything? The only reason to own anything is if its value appreciates. Otherwise, you should lease it or borrow it. And just to summarize a little bit here, so this rethink on circularity as we go from more linear to more circular solutions, certainly there's technological innovations, but the technological focus tends to be on the lower end of this hierarchy. It's recycling technologies, it's remanufacturing technologies. I have a project on remanufacturing right now. It's on recovery technologies and separation technologies. If we look at the upper end of that hierarchy, there's a design focus, and this is what the technical designers like the Delft group is looking at, and the innovations in design. It's the business model innovations that are kicking in. And ultimately, it's socio-institutional changes like insurance or standards or ownership. How are these things going to enable higher levels of thinking of circularity? So my message is our materials are important. Primary sources, I just want to remind everybody, are very constrained. Circularity is a big rethink. We have this whole systems approach that's necessary, this focus on resources instead of waste, which I didn't really emphasize, but we have this anthropogenic resource that's out there that we have to mobilize and access. And what we're looking for is transformative design and business institutional solutions that cut across, that support systemic shifts, that enable high-level circularity and address the real issues of consumption. I had two other points that I didn't get in here that I just wanted to insert. One is I have a conference at the end of the month, and we have a session, actually to riff off what Kelly was saying, we have a session that is informal right now because we've just thought of it, is to work into, we have to figure out what is the science of the circular economy. Because we have it, right now it's this vision, but the science of the circular economy, how do we quantify things? And I'm sure the word LCA is going to come up. But the other thing that is more about this sort of higher level business and institutional change is that of information. The types of products, the composition of products, the number of products, the location of products is something that is very opaque right now. And we need more information available to provide transparency to the market and to inform innovation that would stimulate individuals, stimulate companies to perform those market transformations. I'll thank you very much and look forward to the questions.